In this question, we're told that Chang is investigating how room temperature affects a person's score in a test. She gets Simon to complete the task 11 times at various controlled room temperatures, and that's going to be the X variable, X degrees Celsius. Chang records the temperature X and Simon's score Y, where Y is an integer score, and the results are shown in a scatter diagram below. We're first asked to use the scatter diagram to find the median score. Okay, so here we're actually told to use the scatter diagram. We should be able to pull the median off without having to write down every single value. Let's start by identifying the median position, and we find that with n plus 1 over 2. 11 plus 1 divided by 2. It is the 6th position. When we go through the data, I'm looking for the 6th value, and just from the top down, I'm going to highlight all of the values as I go until I get to the 6th one. This is the 6th value, and that is 11. The median is 11. The range is always the maximum, subtract the minimum, the whole spread of data. The maximum value here is 21, the minimum value is 4, the range is 17. So 2 quick marks there. Next, we're told that the temperature was increased each time Simon completed the task. Chang believes that as the room temperature increases, Simon's score will decrease. Chang calculates the product moment correlation coefficient for her data as negative 0.9286. So that's very strong negative correlation. We're asked to use this value to carry out a hypothesis test to investigate her belief at a 5% level of significance. Once again, they're giving you some pointers of what you need to include. We're asked to state our hypotheses clearly and also to show our critical value. Okay, these are things we should have known to do anyway on a hypothesis test for correlation. The null hypothesis, rho equals 0. Alternate hypothesis, rho is less than 0. Since Chang is looking for negative correlation, she says that as the room temperature increases, Simon's score will decrease. We know that the sample size, n, is 11, and we're using the significance level of 5%. So over to the tables, and we should just be able to see that the critical value, when we look it up at 5%, n equals 11, we get 0.5214. But because we're looking for negative correlation, we get negative 0.5214. On a diagram, on a spectrum of correlation coefficients, that would be here. Now, anything in this shaded region, any calculated result in this shaded region is going to make us want to reject H0. Chang already got a calculated result of negative 0.9286, which is here. It's in this critical region. It's in this rejection zone. We're going to reject H0. Let's write this out. The comparison says that the negative 0.9286 is less than the critical value. We have stronger correlation than the threshold. This is a significant result. We actually have enough evidence to reject H0. We actually have enough evidence to suggest that there is negative correlation between the temperature and Simon's score. In the next bit of the question, we're told that Chang is concerned that because Simon is repeating the same task, his scores are going to improve. He's getting used to the task, so he's got some experience and his scores are going to improve. We're asked to comment on how this concern may affect Chang's conclusion to the test in part B. Well, if Simon is actually performing better at each attempt, but his score is still getting worse, then that actually supports Chang's original hypothesis even more. Because basically that means that these are Simon's improved scores. So if Simon wasn't improving each time, there would be even more of a negative slope. There would be even more of a negative gradient. So it's kind of like we're giving Simon the benefit of the doubt. We're giving him an improved score each time, and we're still seeing very strong negative correlation. This only supports Chang's claim even more.